Welcome students. In this class we will learn to graph the trigonometric function y is equal to sine x. Now foremost what we are going to do is we are going to draw the x-axis, y-axis, and then we are going to place in the points. Now probably I will just extend this. So this is my x and this is my y. Now this is going to be 0. I'll have this point as positive 1, this point as negative 1. I will also stretch this. Now let me start by placing 0 to pi and then 2 pi and then probably maybe 3 pi. And over here it's going to be negative pi, negative 2 pi and negative 3 pi. Now between 0 and pi there's going to be a point pi over 2. Between pi and 2 pi there's going to be a point 3 pi over 2. Between 2 pi and 3 pi there's going to be point 5 pi over 2. And similarly 0 and pi is going to be a point negative pi over 2 and is going to be negative 3 pi over 2. Over here it's going to be negative 5 pi over 2. Now there are a few things we have to know, which is, I want to write it down here. Now sine 0 is equal to 0. Next is sine pi over 2 is equal to 1. Sine pi is 0. Now next value is sine 3 pi over 2 is going to be equal to negative 1. So this is an important value. So these are all standard values for which sine will take. So you need to have these points at the back of your mind. So having obtained these points, we can easily graph the sine x function. So sine 0 is going to be over here, and sine pi over 2 is going to be this point. Sine pi is 0 and sine 3 pi over 2 is going to be negative 1, so it's going to be this point. And sine 2 pi is going to be 0. On the other end, sine negative pi over 2. Negative pi over 2 is going to be negative 1. So this is going to be the point. Sine negative pi is going to be 0. Sine 3 pi over 2 is going to be positive 1. And sine 2 pi is going to be 0. And sine negative 5 pi over 2 is going to be negative 1. In this case, sine 5 pi over 2. Sine 5 pi over 2 will be positive 1. So let me place that point, positive 1. And then sine 3 pi is going to be 0. So I think this is fine. Now, having obtained all of these points, it is important that when we are drawing the graph, it has to be drawn in a curve form, because the graph is actually a wave graph. So you need to have that waveform. So that is important. So I have to ensure that the wave is present here. So I start here, I hit it here, I come down. And over here so it's rising here, it's rising. So this is the sine x graph. So along with this we need to have some important observations. Now clearly the range for this is going to be equal to -1 to +1. So that means it has to be in interval form, -1 comma +1. So both these things are included. And the x-intercept, if you can clearly see, there is an x-intercept at these points. So these are the points that we are having an x-intercept. So we can write that down. So x-intercept is equal to, where do we get it? We're getting it pi, 2 pi and 3 pi. So it's going to be n times pi, where n is a integer, when n is element of integer. So that's important, we need to write that. So we got the range, we got the x-intercept, and the y-intercept, where exactly is the graph intercepting at y? Y is equal to 0. So write that down. So y-intercept is at y is equal to 0. Now the maximum point, so where exactly is the maximum point is taking place? It's taking place at pi over 2 and then 3 pi over 2. So when the x component is pi over 2, the maximum value is 1. So you can write that value down. So the maximum points, so where exactly are we getting the maximum points? We have a maximum at pi over 2, positive 2 times n times pi. So when n is equal to 0, I have a maximum point. When n is equal to 1, it is a maximum point here. The maximum value is going to be 1. So that is where the maximum is taking place. We can say that n is element of integer. So next is the minimum point. So where do we have the minimum point? We are having a minimum point here, and we will also have a minimum point over here. So that minimum point is, first minimum point is occurring as 3 pi over 2. So I can place that 3 pi over 2 positive. It will go on, it will repeat itself. So it's going to be positive 2 times in pi, and the minimum point is -1. So that is critical. Now another important aspect that you need to know is sine x is an odd function. So sine x is an odd function. So that is very important. So what do you mean by odd function? It means that if I were to take sine of negative x, I would get negative sine x. If someone is asking you what is the symmetricity of this function, you can say that sine x is symmetric with respect to the origin 0, 0. So this is a very important aspect. And increasing and decreasing, one wants to know where exactly the sine function is increasing, say from period 0 to the period 2 pi. Clearly you can say that sine x is increasing from 0 to pi over 2, and it is increasing from 3 pi over 2 to 2 pi. So let me write that also down. Over one period from 0 to 2 pi. I need to add that also. So the periodicity of sine x is 2 pi. So that's important. So over one period from 0 to 2 pi, sine x is increasing. Sine x increases from, so where is the increment occurs? From 0 to pi over 2. From 0 to pi over 2, and it also increases from 3 pi over 2 to 2 pi, and 3 pi over 2 to 2 pi. And sine x decreases from pi over 2 to pi over 2 to pi, and anywhere else it also decreases from pi to 3 pi over 2, from pi to 3 pi over 2. So in fact, instead of writing them in parts, clearly you can say from pi over 2 to 3 pi over 2. So you don't need to split it into two parts. You can simply say from pi over 2 to 3 pi over 2. So that would suffice to answer the question. So if they ask you to draw the graph of sine x, you got to put in all of these details. Now specifically if you're going for any competitive examinations, or each one of these can be asked as a question starting from the periodicity of pi, and this completes the solution for this question, students.